While the world watches the headlines, Iran is quietly moving its most sensitive assets deep into the Zagros Mountains. This is Operation Pickaxe, a desperate race to hide a nuclear stockpile under 3,000 feet of solid rock. But the US has a countermove that doesn't involve a single boots-on-the-ground soldier. Today, we look at the bunker buster's secret that has Tehran terrified. Visual, grainy satellite imagery showing mountain construction sites, construction vehicles visible as small dots, excavation patterns visible from space. What you're looking at isn't a mining operation, it's not infrastructure development. This is Iran's most ambitious and most desperate military project in decades, and the clock is ticking on whether they can finish it before the United States makes its move. The threat. Let's talk about what intelligence agencies are calling the underground city. Deep beneath the Zagros mountain range, which stretches across western Iran, construction crews have been working around the clock for the past 18 months. But they're not building up, they're building down. Way down. Visual, 2D cross-section diagram showing layers of the mountain. Here's what we know from satellite reconnaissance and intelligence leaks. The main facility sits approximately 3,000 feet beneath the surface. To put that in perspective, that's deeper than the height of the Eiffel Tower. It's roughly equivalent to 10 football fields stacked vertically into the earth. The facility is structured in multiple layers. Surface level appears as a standard military installation with administrative buildings and vehicle depots. This is the decoy layer, designed to look like any other Iranian military base. Level 1, 500 feet deep. Initial security perimeter with reinforced concrete blast doors, personnel quarters, and command centers. This level serves as the first line of defense against conventional strikes. Level 2, 500 feet deep. Research and development laboratories. This is where uranium enrichment and weapons development activities are believed to occur. Multiple redundant power systems keep operations running even if surface infrastructure is destroyed. Level 3, 2,500 feet deep. Primary storage facilities for fissile material and assembled weapon components, reinforced with layers of concrete, steel, and lead shielding. Level 4, 3,000 feet deep, the deepest secure vault. Intelligence suggests this is where Iran plans to store completed nuclear warheads, protected by the maximum amount of rock and reinforced barriers. The tunnels connecting these levels are designed with deliberate complexity, zigzagging paths, multiple airlock systems, and collapse points that can be triggered to seal off sections if the facility comes under attack. But here's what makes this different from every other hardened facility Iran has built: the sheer depth. Previous installations like Fordo were buried 300 feet down. Natanz had some facilities at 70 feet. This new complex goes 10 times deeper than Fordo. Why does depth matter so much? Because every additional 100 feet of solid rock represents an exponential increase in protection. Iran studied every US and Israeli strike capability for the past 2 decades. They analyzed the bombing of Saddam's bunkers, the strikes in Syria, the targeted operations in Yemen, and they came to one conclusion: go deep enough and you become untouchable. Or so they thought. The intelligence. So why is this happening now? Why is Iran suddenly accelerating construction on these deep mountain facilities? The answer lies in what intelligence analysts call the intelligence gap, the space between what's being reported in mainstream media and what's actually happening behind closed doors. Let's rewind to 6 months ago. In late summer 2025, U.S. naval forces began what was publicly described as routine freedom of navigation exercises in the Persian Gulf. Standard stuff, right? Carrier groups move through the region all the time. But look closer at the composition of those forces. The USS Abraham Lincoln Carrier Strike Group was joined by the USS Florida, an Ohio-class guided missile submarine. Now, these submarines don't typically participate in standard exercises. The Florida carries 154 Tomahawk cruise missiles. It's a first strike platform, designed for one mission: overwhelming precision strikes against hardened targets. Then, in October, something unusual happened. The U.S. Air Force quietly deployed B-2 Spirit stealth bombers to Diego Garcia, a remote island base in the Indian Ocean, roughly 2,500 miles from Iran. Most news outlets covered it for maybe 30 seconds. But defense analysts immediately recognized the significance. B-2 bombers are the only aircraft in the U.S. arsenal capable of carrying the GBU-57 massive ordnance penetrator, the weapon specifically designed to destroy facilities like Iran's underground city. Deploying them to Diego Garcia puts Iran well within range. This wasn't a coincidence. This was a message. Here's what the media isn't connecting. Around the same time as these military movements, Israeli intelligence services reportedly shared critical reconnaissance data with the Pentagon. Sources suggest this included real-time updates on the progress of Iran's underground construction, potentially from human intelligence assets inside Iran's Revolutionary Guard Corps. The intelligence picture suggested that Iran was approximately 18 months away from completing the facility, and potentially 24 to 36 months away from having operational nuclear weapons that could be stored there. That timeline put American and Israeli planners in an uncomfortable position. Do you wait and risk losing the ability to strike, or do you act preemptively? This is the intelligence gap that media coverage misses. News reports focus on diplomatic negotiations, International Atomic Energy Agency inspections, and public statements from Tehran denying weapons development. Meanwhile, the real action is happening in satellite imagery analysis rooms at Langley, in planning sessions at CENTCOM headquarters in Florida, and in quiet conversations between defense ministers in Washington and Tel Aviv. There's another layer to this that's crucial to understand: the technology intelligence race. Iran isn't working alone on these underground facilities. Chinese engineering firms have reportedly provided tunneling expertise, the same technology used to build the Beijing subway system and extensive military tunnels in China's western provinces. Russian consultants familiar with Soviet-era hardened bunker construction have allegedly advised on structural reinforcement techniques. This means Iran is incorporating lessons learned from multiple military traditions. They're not just digging holes, they're building fortresses, using the collected knowledge of three military superpowers. US. Intelligence became aware of this foreign technical assistance through multiple channels: intercepted communications, financial tracking of suspicious payments from Iran to Chinese construction companies, and satellite observation of foreign nationals traveling to and from the construction sites. The intelligence assessment concluded that this facility, once complete, would represent the most hardened target the United States has ever faced. More protected than Saddam's bunkers, deeper than anything in North Korea, more sophisticated than Soviet command centers built during the Cold War. This assessment triggered a fundamental question at the highest levels of U.S. defense planning. Can we actually destroy this thing if we need to? That question leads us directly to the weapon that was designed specifically for moments like this: the tech breakdown. Let's talk about the GBU-57 MOP, the Massive Ordnance Penetrator. This is not your typical bomb. This is a weapon that represents the absolute cutting edge of bunker-busting technology. The basic stats: the GBU-57 weighs 30,000 pounds. That's 15 tons. To give you perspective, a typical car weighs about 4,000 pounds. This single weapon weighs as much as 7 cars. It's 20 feet long and about 1 foot in diameter. It looks less like a traditional bomb and more like a massive metal telephone pole with fins. The entire weapon costs approximately $3, $5 million per unit. The US has manufactured fewer than 2 dozen of these weapons, making each one a strategic asset. The physics of penetration. Now, here's where it gets interesting: the actual mechanics of how this weapon works. The GBU-57 isn't designed to simply explode on impact like conventional bombs. Instead, it uses a principle called delayed detonation with kinetic energy penetration. Let me break that down. First, the kinetic energy component. When dropped from a B-2 bomber at high altitude, typically 40,000 feet, the GBU-57 accelerates due to gravity. By the time it impacts the target, it's traveling at supersonic speeds. The nose cone of the weapon is made from a special steel alloy developed specifically for this purpose. It's not just hard. It's designed to remain structurally intact while experiencing the enormous forces of punching through solid rock and concrete. Here's the critical part: the weapon doesn't explode on first impact. Instead, it penetrates. Imagine throwing a dart at a dartboard. The dart doesn't explode when it hits the board. It pushes through the surface and embeds itself. The GBU-57 does something similar, but at massive scale and speed. When it hits the surface, the nose cone and the weapon's reinforced casing absorb the initial impact shock. The sheer momentum, 30,000 pounds moving at supersonic speed, allows it to punch through the first layer of material. But here's the sophisticated part: the weapon has internal sensors that measure penetration depth. These sensors detect when the bomb has gone through layers of rock and concrete and has reached either a void space, like a tunnel or chamber, or has achieved maximum penetration depth. Only then does it detonate. The explosive inside, approximately 5,300 pounds of AFX 757, a specially formulated high explosive, creates what engineers call a contained blast effect. Because the explosion occurs deep underground, the force has nowhere to go except into the surrounding structure. Think of it like this: if you set off a firecracker in your open hand, the explosion dissipates into the air. But if you close your fist around that firecracker and then it explodes, all that force is concentrated into your hand. The GBU-57 creates that concentrated effect, but with enough force to vaporize reinforced concrete and collapsed tunnel systems. The penetration capability: under optimal conditions, the GBU-57 can penetrate approximately 200 feet of reinforced concrete. In solid rock, depending on the density and composition, it can achieve roughly 60 to 80 feet of penetration. Now you might be thinking, wait, you said Iran's facility is 3,000 feet deep. This weapon can only go 200 feet through concrete or 80 feet through rock. How does that work? Excellent question. And the answer reveals the actual strike strategy, the multi-strike doctrine. The US wouldn't use just one GBU-57. They would use what's called sequential penetration strikes. Here's how it would work. Strike 1. The first GBU-57 impacts the surface and penetrates as deep as possible, let's say 70 feet through the solid rock. It detonates, creating a massive crater and fracturing the rock structure around it. Strike 2. Seconds later, a second GBU-57 hits the exact same spot. Now there's already a crater and fractured rock instead of solid mountain. This bomb penetrates deeper, maybe another 60 feet, and detonates, creating an even deeper crater and further fracturing the rock. Strike 3, 4, 5. Additional weapons continue hitting the same impact point. Each one goes deeper than the last because they're penetrating already damaged material rather than virgin rock. This is called tactical cratering, or progressive penetration. It's like using a jackhammer. You don't break through concrete with one hit. You hit the same spot repeatedly until you break through. Computer simulations run at military research facilities suggest that a coordinated strike using 8 to 12 GBU-57 weapons, delivered in rapid sequence on the same target coordinates, could theoretically reach depths of 400 to 500 feet through combination of rock and reinforced structures. But wait, that's still not 3,000 feet. This is where the strategy becomes more nuanced. The US doesn't necessarily need to reach the deepest level of the facility. They need to accomplish one of three objectives. Objective 1, sever critical infrastructure. Even deep facilities need air, power, and water. These systems require access shafts, ventilation tunnels, and utility conduits. Many of these are at shallower depths, 500 to 800 feet. Strike these support systems, and the deep facility becomes uninhabitable. Objective 2, collapse access points. The facility needs tunnel access for moving materials and personnel. These tunnels, by necessity, must connect the deep levels to the surface. Target these choke points with penetrating weapons, and you can seal the facility permanently, trapping everything inside. Objective 3, induce structural failure. The repeated massive explosions from sequential GBU-57 strikes create seismic shockwaves that propagate through the rock. These shockwaves can destabilize tunnel structures at depths far beyond the direct penetration of the weapons. Think of it like an earthquake. The epicenter might be shallow, but the shaking affects structures miles away. The delivery platform. Remember, only the B-2 Spirit bomber can carry the GBU-57. A typical strike package would involve multiple B-2s, each making potentially multiple runs on the target. The bombers would attack in a coordinated sequence, with each aircraft releasing its weapons on precise GPS coordinates, hitting the same target points to achieve the progressive penetration effect. The B-2's stealth characteristics are crucial here. Iran has sophisticated air defense systems, Russian-made S-300 batteries, Chinese radar systems, and their own domestically produced defense networks. The B-2 would need to penetrate this defensive envelope, deliver its payload, and exit without being detected or engaged. It's worth noting, the U.S. has only 20 operational B-2 bombers in the entire Air Force. They're based at Whiteman Air Force Base in Missouri. Deploying several of them to Diego Garcia, positioning them within striking range of Iran, represents a massive commitment of strategic assets. The geopolitical, so what? Now let's talk about what this all means beyond the technical details. What happens if Iran finishes the mountain shield before the US decides to act? This question keeps defense planners awake at night because it represents a fundamental shift in the regional and global balance of power. The window of vulnerability. Right now, as I'm speaking to you, Iran's facility is incomplete. The deepest levels might be excavated, but they're not fully operational. Support systems aren't in place. Security measures aren't at full capacity. Materials haven't been moved into the facility yet. This is what military strategists call the window of vulnerability, the period when a facility is most susceptible to attack because it's not yet fully protected. But that window is closing. Intelligence estimates suggest that within 12 to 18 months, the facility will reach what's called initial operational capability, meaning it can begin storing sensitive materials even if all construction isn't complete. Once Iran moves fissile material or weapons components into the deep facility, the calculus changes dramatically. The deterrence dilemma. If Iran successfully completes and operationalizes this underground facility, they achieve something unprecedented for a nation of their size and resources. Genuine nuclear deterrence against military strikes. Consider what this means. Currently, if the US wanted to set back Iran's nuclear program, they have identifiable targets, enrichment facilities at Natanz and Fordo, research centers, storage facilities. These sites, while hardened, are within the reach of American strike capabilities. But Once critical assets are moved into a 3,000-foot deep mountain bunker, the threat equation changes. The U.S. would face a situation where they cannot guarantee destruction of Iran's nuclear capability without resorting to extreme measures, potentially including tactical nuclear weapons to achieve the necessary penetration depth. Using nuclear weapons to destroy another nation's nuclear program creates obvious political, moral, and strategic problems. It would alienate allies, potentially trigger regional instability, and set a dangerous precedent. So Iran achieves functional immunity. Their nuclear program becomes effectively untouchable. The regional power shift, Iran completing this facility would fundamentally alter the balance of power in the Middle East. Saudi Arabia has already indicated that if Iran achieves nuclear weapons capability, they will pursue their own nuclear program. They have the financial resources and have maintained relationships with Pakistan, widely believed to be a potential source of nuclear technology. Turkey, Egypt, and potentially the UAE would face pressure to develop their own nuclear capabilities or seek security guarantees from nuclear powers. The Israeli factor. For Israel, this isn't theoretical, it's existential. Israeli military planners operate under a doctrine called Begin Doctrine, established in 1981 when Israel destroyed Iraq's Osirak nuclear reactor. The principle? Israel will not permit hostile nations in the region to acquire nuclear weapons capability. Israel has previously conducted strikes against nuclear facilities in Iraq, 1981, Syria, 2007, and allegedly covert operations in Iran. But those targets were accessible. If Iran's underground facility becomes operational, Israel faces a crisis. Their air force doesn't possess weapons comparable to the GBU-57. Their largest bunker busters can penetrate maybe 30 to 40 feet of reinforced concrete. Impressive, but insufficient against a 3,000-foot deep facility. This means Israel would become dependent on U.S. willingness to act. And if the U.S. decides not to strike for diplomatic, political, or strategic reasons, Israel is left without options. Some analysts believe this could push Israel toward more extreme measures, including the use of their own nuclear arsenal. Israel maintains a policy of nuclear ambiguity, but is widely believed to possess between 80 and 400 nuclear warheads. The scenario where Israel feels cornered and considers a nuclear first strike to prevent Iran from achieving nuclear capability is nightmare fuel for anyone who thinks seriously about Middle East security. The diplomacy deadline. All of this creates an invisible deadline for diplomacy. Right now, diplomatic negotiations with Iran continue. The U.S., European powers, and Iran discuss sanctions relief, nuclear restrictions, and inspection regimes. These talks proceed at the leisurely pace of international diplomacy. Meetings, proposals, counter-proposals, more meetings. But the construction in the Zagros Mountains doesn't pause for diplomatic niceties. Every day the facility gets deeper, more complete, more operational. This creates what negotiators call deadline pressure. The knowledge that past a certain point, the conversation becomes irrelevant because facts on the ground have changed. If the U.S. intends to use military force, they need to act before the facility becomes operational. If they intend to use diplomacy, they need to reach an agreement before Iran feels secure enough in their underground fortress to ignore diplomatic pressure entirely. The domestic political dimension. In the United States, this issue carries enormous political weight. Any American president who orders strikes on Iran faces massive domestic and international blowback. It's an act of war against a nation the U.S. is not formally in conflict with. It risks regional escalation, potential American casualties, and economic disruption. But any American president who allows Iran to achieve nuclear capability while having had the option to prevent it faces equally severe political consequences. They would be blamed for failing to act when action was still possible. This creates a political trap where both action and inaction carry enormous risks. The so what? Bottom line, here's what it comes down to. If Iran finishes the mountain shield, the United States loses its military option without resorting to measures, like tactical nuclear weapons. That would be politically and morally catastrophic. Iran gains effective deterrence against military strikes, fundamentally altering the regional balance of power. Nuclear proliferation across the Middle East becomes likely as neighboring nations respond to Iran's new capability. Israel faces an existential security crisis that could lead to extreme and destabilizing actions. And all of this comes down to a race between Iranian construction crews digging into a mountain and American decision makers trying to determine if, when, and how to stop them. The clock is ticking. And unlike the slow pace of diplomacy, physics and geology don't care about political considerations. Every day that passes makes Iran's facility harder to destroy and makes the decisions facing Washington and Tel Aviv more difficult. Let's bring this all together, the summary of the board as we call it. What we know. Iran is constructing an unprecedented deep underground facility in the Zagros Mountains, designed to shield nuclear materials and potentially completed weapons under 3,000 feet of solid rock. The United States has positioned strategic military assets, including B-2 bombers carrying GBU-57 bunker buster weapons, within striking range of Iran. Intelligence assessments suggest a closing window of 12 to 18 months before Iran's facility becomes operational and effectively immune to conventional military strikes. The geopolitical stakes extend far beyond just U.S.-Iran relations, potentially triggering nuclear proliferation across the Middle East and creating an existential crisis for Israel. What to watch in the next 48 hours? Here are the specific indicators that would suggest military action is imminent. 1. Movement of additional B-2 bombers, from Whiteman Air Force Base to Diego Garcia. If you see reports of multiple B-2s deploying simultaneously, that's a major signal. 2. Increased U.S. Navy presence in the Persian Gulf and Gulf of Oman. Specifically, watch for additional carrier strike groups or Ohio-class submarines in the region. 3. Diplomatic activity, or the sudden absence of it. If scheduled talks with Iran are abruptly canceled, or if there's a sudden withdrawal of diplomatic personnel from the region, these are classic pre-strike indicators. 4. Israeli military readiness levels. Israel's Home Front Command has protocols for alerting the civilian population about potential regional conflict. Any changes to these readiness levels would be significant. 5. Oil market reactions. Major oil traders have access to intelligence that doesn't make the news. If you see sudden spikes in oil futures or unusual options activity betting on price increases, informed players might be anticipating conflict. What this means for you. If you're watching this video, you're probably interested in geopolitics and military affairs. This situation represents one of those rare moments where theoretical capabilities meet real-world decisions with global consequences. The technical details matter. Understanding how the GBU-57 works, why depth provides protection, how sequential strikes overcome hardened targets. These aren't just academic questions. They're the factors that will determine whether we see military conflict in the Middle East in the coming months. The strategic considerations matter even more. Understanding why this facility changes deterrence calculations, why the window of opportunity is closing, why both action and inaction carry enormous risks. The bigger picture. The situation illustrates a fundamental challenge in modern warfare, the race between defensive capabilities and offensive technologies. Iran studied American strike capabilities and engineered a defensive solution. Go deep enough and you're safe. America developed the GBU-57 specifically for deeply buried targets. Iran responded by going even deeper. America developed the sequential strike doctrine to overcome that depth. It's an arms race conducted in engineering specifications and mountain geology rather than missile counts and troop numbers. The winner of this particular race will be determined not in some distant future, but in the next 12 to 18 months. Either Iran completes their facility and achieves effective immunity, or the United States acts to prevent that outcome. Your action items. If you want to follow this situation, track U.S. military deployments to the Middle East through official Department of Defense releases and military aviation tracking sites. Monitor statements from the International Atomic Energy Agency regarding Iranian nuclear activities. Follow Israeli security analysis from sources like the Institute for National Security Studies or International Institute for Strategic Studies. Watch for changes in oil markets and regional military readiness indicators. Or final thoughts. Operation Pickaxe isn't just about Iran building tunnels or America having fancy weapons. It's about the fundamental question of whether nuclear proliferation can be prevented through military means in an era where defensive technology has advanced to the point of potentially negating offensive capabilities. The answer to that question will shape Middle East security, global nuclear politics, and American military strategy for the next generation. The race is on, the clock is ticking, and the decisions made in the next few months will reverberate for decades. Thank you for watching. If you found this analysis valuable, subscribe for more in-depth coverage of military technology and geopolitical developments. And drop a comment. What do you think happens next? Does the U.S. strike? Does Iran finish the facility? Is there a diplomatic solution we're not seeing? The board is set. The pieces are moving. Now we watch to see how this plays out.